I want to preface this by saying that this project is still in its early stages. What you see here may change over time as I fix bugs, add new features, and just generally improve the tool. If you have any questions, please do leave them in the comments on the GitHub repo, ping me an email, or even jump in our Discord, and all of that will be linked in the description. If you don't happen to have an open source latency testing tool, but you want one, you can head to OSLTT.com and pick one up. Right, let's get into the tool. Physically, you'll find a few main ports and inputs. On the side, you have the USB-C port as well as the microphone jack. I'm including a microphone with these kits, but if for some reason you want to use your own, you'll need to make sure that it is a microphone jack or TRS and not a combined headphone jack or 4-pole TTRS jack. On the top, you'll find the indicator LED, the 2-pin input, and a crosshair built into the case to help you more easily line up the sensor that's on the bottom with whatever you want to track on screen. On the top side, you'll find the orange button that is used to trigger some of the tests, or in the case of the mouse and keyboard test mode, you'll actually use that to end the test too. On the bottom, you'll find the light sensor and the two 2.5mm Allen key screws that hold the unit together. Not that you'll need to get into this, but if you do want to look inside, you just remove those two screws and just pull the case apart. When it comes to the 2-pin inputs, it's really important that I make this clear. When looking at the device from the top with the button facing away from you, the top pin is ground and the one closer to you, the bottom pin, is the one that you apply a voltage to, the signal pin if you will. If you bought the fly leads from me, the one with the white sticker on the wire is the signal wire, and the other one is obviously ground. In an ideal world, you would supply 3.3 volts to the signal wire, although just in case, I've isolated the microcontroller so you can technically supply up to like 50 volts without the transistor blowing up. Now to be clear, please don't, but if you do by accident, I've designed it with a bit of safety just in case. Right, so that's the hardware. To get it working, you'll need to install the software. Head to the GitHub repo linked in the description, specifically to the Releases tab, and download the installer executable. Once you install it, it will install to C/OSLTT, and once you open it for the first time, it will ask you if it can do some additional installation, specifically the tools it needs to detect and update the board. Hit yes, and then it will ask you to install 2 drivers, one from Arduino and one from Seed. Once that's done, if the firmware needs to be updated, it should ask you to do that too. Mine obviously doesn't, so onto the software itself. I've tried to keep everything front and center so there aren't any hidden options. You've got the preset modes at the top. These just change what is selected in the options at the bottom. So monitor testing uses the light sensor, button trigger, and DirectX code that I wrote. The mouse and keyboard testing preset uses the microphone to trigger it, and the click key presses, capture, and test source. If you want to tweak any of these settings, you can always hit the custom preset button and change these to your heart's content. These will also save so that when you next open the program, they'll all be ready to go. You won't have to reset up anything. There are a number of configurations that, while they might be useful, at the time of filming aren't currently supported, so the options menu won't let you pick something that just outright won't work. With time, I do hope to support plenty more different modes, and if there are any specific configurations that you would like, please do let me know, ideally on GitHub, so that I can keep track of those sorts of feature requests. Let's talk through some of the tests. I'll start with the one that I'm sure most of you are interested in, which is the mouse and keyboard peripheral testing mode. Specifically, that is just mouse and keyboards for now. Hopefully I can add things like controllers later, but we'll get onto that in the future. You need the microphone connected to the device, and here's the important bit. The mic needs to be right up next to the device you're testing. Right next to the left click button if it's mouse testing, or right next to a keyboard key if you're going to press them. Select the mouse and keyboard preset, hit Start Test, and then you just click in the box on the window or type in the box below that. You will need to make sure that your clicks and key presses are nice and loud, something like that. Do as many clicks as you want. The more you do, the more accurate the final results will be. And then once you're done, click the orange button on the device to end the test. Clicking End Test will technically work, but at least at the time of filming, it will sort of soft lock the device as it's waiting for you to, press a key again, and so you'll need to unplug and reconnect the device if you end up doing that by accident. You should then see the results viewer pop up with all of the data. What shows up here is subject to change, but in short, you should see a graph with the click times, average, minimum, and maximum, and if you hit switch to individual results, you'll see the scatter plot of each individual data point. You can also save those charts as images, either with a transparent background or a white background if you prefer. Moving on to the monitor testing mode, this is the exact same test as the input latency testing mode on OSLTT. So all you need to do is strap it to your screen like you would with OSLTT, and then make sure that if you have multiple monitors selected, select the right one in the monitor selection drop down, and then just hit Start Test. Your screen will go black as it launches the DirectX program. You'll see an FPS counter at the top left. You want to wait till that is sitting stably, ideally around 1000 FPS, and then hit the button on the device. Your screen will flash as many times as you set in the software. By default, that is 100 for the most sort of reliable data while still not taking absolutely forever. Again, once it's done, you will see the results view with all of the data. This time it will include the USB polling delay, the render time, and the on-display latency. The latter there is basically the time it takes from the GPU sending the frame to the monitor starting to display it. The audio latency test is pretty simple too. Stick the microphone in the ear cup of the headset you want to test, or in front of your speakers, just whatever you're testing, and then make sure that the volume is turned as high up as it will go. The louder the beep, the clearer the results will be. To start, hit the button on the device to trigger the test. By default, this will run for 30 times, although you can increase it up to 500 if you want to go that kind of mad. Once it's complete, it will pop up the results here with all of the data for you. If you fancy testing some games, you can hit the game mode, hit Start Test, and then fire up your game of choice. In my case, I'm going to go with CSGO. It needs a relatively considerable light level difference to detect, so I like to stand by these metal signs and have it shoot the signs, which produces a much brighter flash than the pistol itself. If the game has NVIDIA's reflex latency marker, that will work great too. Again, by default, once you hit the button on the device, it will auto fire. I go with 20 shots here, as that is the size of the magazine, of the pistol magazine in CSGO. If you use the auto fire mode, it should actually automatically end the test once it's complete, or you can turn off auto click and just press the button as many times as you like to single fire it. And lastly, there is the external mode. If you want to test something else entirely different, you can use the light sensor and either the button or the 2-pin input to trigger it. It will still process the data all the same, and if you're doing something that the software can't process right now, it will still save all of the raw data to a CSV file, which you can then manually graph in Excel to check through yourself. Also, just so that you know the format, the first column is the click time in milliseconds, the second column is the frame time, which will be 0 if you aren't using the DirectX mode, the third column is the total time it took to capture all of those samples that are in the file, and then the fourth column is the number of samples that it is taken. You can use those two, the last two numbers, this total time taken and the number of samples, to work out how long it took between each of the samples. So for the light sensor data, that should be around 15.1 microseconds, and for the audio data, for audio latency, that should be around 35 microseconds. If, for example, you wanted to run multiple auto-click tests in a game, you can manually combine the raw data results and then just open the results viewer and hit the import File button. It will then reprocess those files and give you a new set of averaged results. You can also import existing processed files if you want to just view them in the results viewer. I think that mostly sums up all of the features and functions that this has, at least at the time of filming. If you have any questions about any of it, feel free to, like I said, leave them in the comments, head over to the GitHub repo, ping me an email, or even jump on our Discord and head to the OSRTT, OSLTT support channel. All of that will be linked in the description, and of course, if you don't yet have your own open source latency testing tool, but you want one, you can head to osrtt.com and grab one. I hand build all of these units myself and validate them before shipping, and of course I'm writing all of this software myself, so if you do find bugs or you want any features added, feel free to let me know in any of those ways, ideally on GitHub, especially for the features and issues. But either way, let me know, and please be patient, because I am both obviously solo doing all of this and running a YouTube channel and running the open source response time tool, and I'm also just quite disabled, both mentally and physically, so please bear with me, but I do very much want to get both this into everybody's hands and to add as many features as possible to make it as useful as possible, so do feel free to let me know what you'd like to see, but also please be patient. Otherwise, that is kind of it. If you want to see more videos like this one, stay up to date on any extra features I add, feel free to hit the subscribe button and turn on the bell notification icon. If you want to check out the video talking more about the hardware and how it all works, check out that video on the end cards. And otherwise, that's kind of it. If you want to support the project, but you don't necessarily need one of these tools, there's a load of links in the description you can use. And otherwise, thanks for watching, hope you enjoyed it, and we'll see you on the next video.